Gregor is the CTO of Orca AI. He is a technologist with a deep background in software development, high-performance computing, AI, large-scale information analytics, data forensics, and IT operations. For over 30 years, he has worked across numerous industries, ranging from gas and oil exploration through to the legal industry. His focus is on how to make sense of large data stores and how to bring dark data back to life.
Good morning and good afternoon, everyone. My name's Quinn, and I'll be walking you through a lot of information. Some of this I'm going to gloss over, so you can go and look at it on YouTube later on. What I'm going to be talking about today is the challenge of dealing with unstructured data. Unstructured data is generally, in terms of my world, it's text. 80% of unstructured data is text, and dealing with very high volumes of data when you're trying to search it's impossible to read through it. So AI and machine learning have made a massive difference to this industry. We've been involved in this space for off and on for 20 years. In terms of how the opinions have changed over the last 6-7 years as to how to use this technology. So today I'm going to be talking about a very real example of somebody coming to someone in IT saying, hey, I need all the files for a particular product. We have a product liability case, product liability issue. So I'm going to talk about how you think about data retrieval, how you tune your data searching and your production to what the requester might actually need, and how you leverage AI to hone in on what you really need, and then ultimately what you should do to make sure everybody's comfortable with the work that you've done. So why am I talking about this? There's a definite shift in corporate information management needs. People are recognizing that AI can do more and more. So this is coming in-house. The key drivers are the colossal data volumes, costs of information management and retrieval, the desires not to send information outside to third parties, and obviously the speed and accuracy which AI and ML actually lend to this type of operation. Simply put, the legacy search tools, in other words, keyword search, which is generally what most people have, these do not scale. So today we're talking about a fictitious product warranty issue. An executive comes in to you, the IT guy, and says, hey, I need everything for product ABC 123. Get this done now. Just get it done. I need it. Where do you start? If you try and go old school and simply look through email and read file at a time, you're never going to get this done. So you need the help of machines and you need the help of AI. And so that's what we're going to focus on today. So if you're starting with all this data, it helps if you try and frame what they're asking for. Whether it's a product or a person or whatever they're looking for, start with some simple questions. Try and hone in on the field. So simple questions I would be asking, when was the product first developed? How much information do you really want? Do you want stuff prior to it being a live product? What are we going to do with this information? What's critical with any information you pull out using machine learning and what have you is how you handle the metadata. If you corrupt the files accidentally, then the information is now suspect. Can you give me a clue who might have been involved? This is generally a guess, and I'll discuss that more in a few minutes because, institutional memory, your boss may have only been there 2 years. They've got no idea what happened 5, 10, 15 years ago. So ideally, we're going to start small. We'll think about somebody in engineering, sales, marketing, legal. And then there is, okay, we have a product name. What are the other names this product was known by? And finally, how do you want this information stored and presented? If we think about a typical departmental storage scenario, Data is stored based upon network needs, the software packages you've got. It's not stored with retrieval in mind. And so you can have these silos. They can be in different offices, different locations. Some may be local, some may be in the cloud. So trying to figure out what is where can be very challenging. So where do you start? The goal here really is to shrink the data ocean to a data lake and ideally a data puddle. If you consider a small to medium-sized company, just a small company with 5,000 employees, if you've got a series of backups and you're looking through those backups, that's easily 100 million documents. Keep in mind that people read at a rate of around 50 documents an hour. So that's a lot of reading. Institutional memory, as I said before, it's usually a best and bad guess. So what are you going to do? You've got to use AI, but you can't quickly pull all that information back from your storage. You've got to try and focus. Now, so one of the easiest things to do, a Google search will tell you when the product first hit the market. And that may be a lot better guess than the person who's standing there in front of you saying, hey, it's 5 years ago. I've had people tell me it's 5 years ago when it was actually 7 years ago. So think about this carefully. The next important thing is to start small. Test, validate, measure. As I said, ideally, if it's a product situation, you've got to think about who might have created this, who tried to market this, sell it, and so on. So identify people in those departments and then try and scale out. Best place to start is email. Email still is the universal file exchange mechanism. So contracts, design, proposals, all of this will be in the email somewhere. If you're dealing with backup tapes, and some organizations still are, go to the year-end backups first. Pull out, if you can do it, email files such as PST files, personal storage table files. Or if you're dealing with cloud-based or disk-based backups, again, target people, senior people now, who've been with the company for a while, and just poke around, just take a year at a time and see what you get. Be very, very careful not to alter the metadata because that's going to invalidate all your hard work. The goal here is to teach the AI, looking at the small group of people, and then to iterate through and add more and more content. And the machine learning will end up doing most of the work. And at the end of the day, you're going to measure performance and you're going to infer overall document population. So I've talked briefly about can't read it all. You need help. You need a text analytics platform. And so I'm going to talk about what we do. Other people do what we do, so not just us. But what I'm going to focus on today is the first half of this, basically the content analysis, understanding who communicates, understand volume, understand language, and then machine learning and how you interact with that and how you teach it. And I'll leave the rest of this for some other time. But essentially, these are the tools you need for a good text analytics platform. Key to this is an idea called concept search. Concept search has been around for 20 plus years. The idea of concept search is that a word's context defines its meaning. So if you're given a product name or a dummy name, you can learn about that based upon the other words and language around it. And from that, you can do link analysis. There's a very famous bankruptcy called Enron, which some of you will have heard, and Enron's really good test data for us in the AI world. But if you start to look at their test data, you'll see that it's all based around Star War names. So why concept search and not keyword search? Well, you've got keyword search. There's plenty of great keyword search tools. We're all familiar with Google. The challenge you get is, it's a list here. I'll go through a couple of them. Failure of imagination. What you think about is based upon your imagination, your bias, or someone else's bias. And they'll say, well, it's this and this and this. And that's their view of the world. And when you find a few of those examples, you think, okay, that's all there is to find. The reality is keyword search misses 80 to 90+% of the relevant information, whereas machine learning, if it's properly trained, will find far more than that. So let's start to talk a bit more about concept search. It is a very powerful tool. How do you go about training a system on concept search? Concept search, it's a form of unsupervised learning, so to speak. It's a result of how the data is indexed, and there's a bunch of math behind this. You can go and look up the patents on this. This right-hand example is I'm looking for cash, money, and fraud. Those are just three ideas I wanted to go looking for. And you can see the system here is saying, listen, the main ideas in this particular collection is corporate, money, and guilty. So it didn't do what keyword search would have done, which is return the words cash, money, and fraud. In fact, you can see money, but you can't see the word fraud on that collection there. And you can't see the word cash easily on that collection there. So, but what it has done is given you a lot more ideas to think about, a lot more words to think about. So in terms of, again, trying to shrink your data lake down to, or your data ocean down to a data lake, concept search is going to help you start to fine tune some of the information. So you're going to put in the product name, and you're going to get other product words back from this. And you may even get some of the earlier product names, because the earlier product names might have been used by the engineering team versus the marketing team. Next thing to think about is, well, who am I really going to search on? What are we looking at here? It's a bit of a, this screen is a bunch of whites and reds and blue lines and what have you, but what we're showing here is communication, and the red dots are the people sending, and the white dots are people receiving. And if we look at the left-hand side, this is, showing a simplified version of everyone talking about a topic. Again, who do you focus in on? Who are the people you're really going to learn from? And so if you say, listen, I wanted to eliminate those who've simply done one email exchange or may have been on a receiving of a bulk email, in this middle slide, you can see a much thicker blue line. And that's showing you, hey, there's some definite strong communicators here. And again, if you zoom in and say, listen, I really want the main communicators about a topic, if you look at the lower right-hand slide here, it's showing these red dots, and these are the main people talking about this subject. So this is a noise reduction exercise. This really shows you who you should be focusing on first. The next challenge is trying to figure out when did the product come out? And so we like to do volumetric analysis next to a concept search. And so what this allows you to do, again, is shrink your overall volume. If you look at the top graphic here on the right-hand side, on the left-hand side, you'll see volume of email per time period. And then you can see something was happening in 2003, and basically by 2014, everything is done. But it gives you sort of a 10-year lifespan for this product. And you can see there were several key events. These spikes are going to show you key events in the lifespan of this particular product or this particular search. The image below that, if you zoom way into this, you can now see the individual file names, and you can start to see what people are talking about, and you can go and select those. And this bottom image is showing back to what I was talking about earlier on, data being stored everywhere. You have to ensure that you do not have gaps in your data. You may have had an email server that moved from one location to another location, and you may have a gap in someone's email. And if you're the person who came to you saying, hey, I need all this information, you said, well, here's all the information. And suddenly, 3 months on, there's this 9-month gap of missing content. You're going to be called on the carpet. You're not going to look very good. So do check what you're doing. So these types of tools are really useful to help you understand how much data you've got, and whether or not you have completeness of information. Again, looking at this bottom one, you can see nice high volume through 2006 and 7 and 8. And then 2009 and 10, the volume drops way off. So something's wrong with how this data retrieval was performed. So let's talk about sampling. The idea of sampling is you start small, and you'll see, I'll present this graphic a couple of times, but you'll see on the top left-hand side, you'll see where it says collection 1, collection 2, collection 3, and then a sort of time period. The idea is you start small, you identify, you get the data, you ingest it, you start poking around with the analytics, and then you start the data classification. So that's when you start the AI training, the machine learning training and processing. And then from there, you start to look and learn, and you figure out, hey, who else am I going to involve? So that's what we're going to cover over the next few slides. So essentially, you can come back to this at another time, but the idea is to, again, small and expand out. Another key point here is people cannot spell. Look at the right-hand side, this word Houston. How hard is it to spell Houston? Apparently, it does challenge some people. If you've got a funky product name or a funky location name, we were looking at one thing, it was Fontainebleau, over 50 spellings for the word Fontainebleau. So if you've got this type of capability, you can capture these additional spellings, and again, it will help you not miss content. Okay, so let's talk about some artificial intelligence in the form of clustering. So what's clustering? Clustering is it's also known as machine learning. It's unsupervised learning in this case. In this case, what have we done? We've looked at, in fact, we haven't looked at, we've simply fed documents into a system. The machine has looked at the documents and said, mathematically, these are the main themes, these are the main terms in the document collection, and it's gone and brought the terms together. So you see this red circle, the bottom middle of the screen. All those documents are actually sports terms, but in this case, they're all brought together. So the colors don't mean anything. The thickness of the lines is showing, listen, there's more communication between them. And when you have them tightly overlapping, that's them clustering. So generally, you can say these are all about the same subject. They may be using different words. People may be using word substitution. When we were doing mortgage analysis, for example, people were using the terms poop and poopy next to all the mortgage terms, and the clustering revealed how some of the mortgage fraud was done. So clustering is a really rapid way for you to learn language, alternate language, and again, back to trying to find all the data about a particular subject. This form of machine learning is very, very powerful. Generally, the way we use it is we will get in a good example of documents that we want. We will set up our base clusters, and as we add more documents to those clusters later on, they will automatically fall in under those. So we can start to zoom in, and we can click on one of these words and go and see the documents behind these. Let's talk about the much bigger picture. You've gone ahead and you've looked at people, and you've gone and selected your 4, 5, 6, 7, 8 people, however many it's going to be. You've gone and selected the time frames for when the documents are relevant versus likely not relevant. You've gone and said, well, because we're looking at text versus images versus databases, I'm going to constrain what goes into my text analytics classification engine. So at the top of this, you'll see reference to a sampling frame. So you define your population. You then pull a sample of 100 documents out, and you get a single person. Now, why do we want a single person? We want a subject matter expert. This can be an engineer, it can be anybody who knows about the topic. If it's a legal matter, sometimes it's a lawyer, sometimes it's an engineer. But you want one person and one person only. The reason you want one person and one person only is if you put 2 or more people on the same documents, you're going to get disagreement. And the level of disagreement can be as much as 40 or 50%. There is a number of studies that have been performed. Jazzist has got one on this particular topic, and it shows just how people's biases get in the way of their judgment. So pick on one person, and their job is to look at document by document and tell the computer, yes, it's responsive to this product inquiry, or no, it's not. And after you finish your first sample of, say, 100 documents, the computer's going to learn from that, and you're going to pull another random sample. And from there, again, the expert's going to look at this. And as you start to iterate through this, the computer's going to start to predict. So the machine learning looks at the phrases, it looks at a particular document and says, does this contain similar patterns to these earlier documents that you told me you liked? And it will present those as being responsive, and you're going to say, yes, I like it, or no, I don't. And so the computer's going to learn pattern by pattern by pattern as to what you like versus what you don't like. So, for example, if we have a document that says, I'll see you at the pizza party on Saturday night. Oh, by the way, the $5 million we borrowed is now in that Swiss bank account. So what's the computer learned? It's learned about pizza parties. It's learned about Swiss bank accounts. It's learned about $5 million. If other documents come up about pizza and you tell the computer, no, I don't like those, the computer starts to unlearn pizza, but it still remembers Swiss and bank accounts and other stuff. So it's a positive reinforcement method, but it's not set in its ways. This is a nice adaptable model. As we go through, we measure precision and recall. And we'll come across those in a few minutes, so I'll explain what they are. But we're measuring precision. And when we get high rates of precision and recall, and we basically have stopped coming across new examples of ideas to teach the computer, that's essentially our stop point for training the computer. So depending on prevalence is a measure of richness. If you've got documents that are very prevalent, you could have 8, 10, 12% of your population generally talking the product. That makes your training very, very rapid. In other cases, you're going to have very sparse or very low prevalence, and you may have to read through an awful lot of documents to actually find something that is relevant. So there's alternative ways we can teach the computer. But generally, if you've done a good job of setting your initial sampling frame, you should be able to train the computer in 10 to 20 hours. Once you've got to the point of a trained model, push the go button and the computer goes ahead and it reads and classifies at about 1 million documents an hour. with very high rates of both precision and recall. So let's talk about precision. For those of you who've been panning for gold, fun thing to do, not this time of year, it's too cold. But essentially, when you find this nice shiny object, you go, well, how much of this have I got? What percentage of all the available golds in the pan? How much of the documents I got are responsive? And likewise, recall. You find these big nuggets and you go, oh, I wish I had more like these. Did we find all those big gold nuggets? Did we find all those responsive documents? So we do look at these, and we want high rates of precision and recall. It's important that we focus on both. Some people will tell you, oh, we can get high recall, but our rates of precision are low. That's because they're using inferior technology. There's better ways to do things. Let's talk about quality control and confidence. First of all, don't invent your own statistics. Very good book by Albertson on statistics as a principled argument. This confidence table comes from that book. Generally, this is like exit polling. You don't have to speak to every single person to know who's actually won. You take a small sample. We like to use a 95%. We'd like to go for a 95% confidence level. And we like to go for a margin of error or plus or minus 5%. And you can achieve that by looking at just 384 documents. So how do you do that? You take your output from your machine learning run, you look at 384 documents, and you go through and go, yes, the computer got it right, the computer got it wrong, and you, whatever that pile of correct versus not correct is, you can now say with confidence that that ratio is correct with 95% confidence plus or minus 5%. So that tells you one thing, but essentially, did you get the right documents? Was the person who was training the system good? Did you have the right subject matter expert? Was the person's judgment too narrow? Did we miss content, or did they do a fantastic job? If that person was to look at the same documents, would they change their mind before lunch and after lunch? Lots of things to think about, because ultimately it's a human making the decision, and the humans will change their mind before lunch, during lunch, and after lunch. So confidence level and confidence interval do not address any of these questions directly. You've got to basically look at these, and you've got to figure out how good a job did this person do. So QC is important. If you're dealing with opposing parties, if this is a legal matter, before you get into this, discuss up front how you're going to measure and come to agreements on measurement. It's very, very important. Humans, when they're looking at documents, generally can find between 20 and 40%. The computers, depending on the software, find between 50 and 90%. So set your bar reasonably and agree with either those inside your company or outside of your company what level of performance you want, but make sure that when you're measuring, your measurements are going to be consequential. The important thing here is, again, you can't read everything. So essentially what you're doing is you're taking a measurement, and you're taking a small population and you're measuring, and from the behavior of that population, you are inferring the behavior of the overall population. So you finished your first iteration through the data. You finished collection number 1 up here. And collection number 1 is essentially your baseline. You've now got what we refer to as a language model. It's got an idea of the words, the phrases, the content you're looking for. You can now look at those results, and you can go back to the communication analytics and say, in my results, who are the people talking? Who else are they talking to? And you can start to look more carefully at those people and go, well, perhaps I need to bring those people. So in this collection 2 ring, you'll see this green ring around the outside. These are the people now we're going to add to the second collection. And essentially, you're going to iterate through the same process. You're going to run through additional classification. It shouldn't take as long, because essentially you've already got your starting point. And now you're going to add their content in on top of your initial language model. Again, you're going to tell the computer to go do its job. And you may want to do the same thing for a third time. It may or may not be necessary. Again, go through your training, your QC, and see what comes out at the far end, and see how accurate the computer is. If the computer's still learning, you may want to add additional people to the training process. If you think about this, if you're talking to a bunch of engineers, they're going to talk about the product one way, so the computer is going to learn that language, versus if you're talking to a bunch of salespeople, they're going to be talking about it a different way. Ideally, they're using the marketing language that the marketing team wants, but they'll be using different language. And the legal team, and those doing the patent that protects your intellectual property, they'll be using different language too. And then there'll be the regional language based on Northeast, Southeast, and so on. All of that is going to have a bearing on your overall accuracy and your machine learning effectiveness. So iterate through a few times, but essentially what you have to think about is reasonableness of process versus being exhaustive. You will never find it all. It's not reasonable to find it all. And keep in mind that if humans were doing it, they would find a small fraction of what you're going to find with AI and machine learning. So if we're talking about effort, again, your boss has come to you and said, listen, I need all this stuff now. If you were doing keyword search and review, I mean, this is from one of the investigations that we help a company do. And they estimated that, actually what they did do with us is they decided to do an A/B test. They did this internally, and it took them just under 1,100 hours. We did this with the machine learning. We've actually had to increase the numbers so they show on this chart, but it took 17 hours versus 1,100 hours, and we had greater accuracy. Another way to think about this is the financial impact. If you are involved in a legal dispute, or it's an internal dispute, or it's an internal discovery, or you're trying to protect something, all of this information retrieval takes time and it costs money. And the more imprecise you are, the more work somebody else or other people have to do downstream to get past the false positives. So if you look at this curve here, basically what it's showing you is if you have 90% recall and you only have 20% precision, that means 1 document in 5 is on point. In other words, 4 documents in 5 are not. That's a waste of everyone's time. So the next big thing here is documentation. Regardless of whether this is for an internal or external use, again, your IT, they don't know what you've done. Somebody else may be coming along behind you to do additional work. But as you progress, you've got to document the decisions you took, where you looked, where you ignored. No, we're not looking at these servers. They've never been used for email. There's going to be stuff which is just too old. The term is called technically inaccessible. And you have to document, hey, I couldn't get here, or this is offline. And then, again, depending on the circumstance, you may be required to talk about which version of which tool you used, which operating systems, which methods. Some tools give better results than other versions of the tools. So Again, from in terms of how we got to where we got to, very important that you track this. Also keep track of volumes in, volumes out. Start to think about how you trained the analytics platform. Who was your subject matter expert? Why did you select them? Your precision and recall rates, your first time through, your second time through, where there were issues with the machine, perhaps picking on the wrong area or the right area, and generally, essentially, an overall performance report. And most importantly, share your work with others as you progress and have others QC and audit what you do. Crucial year through all of this. There's many, many uses for this type of technology, depending on your position in the company. There's many ways to think about how you use machine learning to add benefit to your company, whether it's security, audit, compliance, risk management. Every one of those particular departments, users, they have jobs they're trying to do. And machine learning and AI can be used to greatly facilitate all of this. You can literally put this in a proactive fashion. So as the data is streaming into your data lakes, you can put your machine learning on the front of that, and it will alert for security or it'll alert for risk management. For business users, if you think about business users today, generally they are looking at the structured data. So they're looking at what comes out of their spreadsheets and their business analytics tools. The business analytics tools don't look at text at all. It seems amazing that business users are making all these great business decisions, and they're ignoring over half the available data. So text analytics can greatly help business users make more informed decisions. Anyway, lots of ways to use this technology. So I'm going to wrap up now. In terms of today, we've talked about starting small. We've talked about scaling up and out. We've talked about sampling. We've talked about avoiding bias. Now, bias is a really important point. If you try and force your vision of what the data should be, chances are you're going to get upset. Let the data tell you what's going on and see what it's telling you. Let it tell you who communicated to whom and when, rather than you thinking, oh, so-and-so would have spoken to so-and-so about this. We've used this to define the project teams, the engineering teams, the sales teams, and so on, purely from the data. And whether it's 5 years, 10 years, 15 years ago, if you use these tools correctly, they can show you who, why, when, what, and so on. Learn to use the visualizations. The visualizations, if they're carefully thought through, can give you a lot of clues. If there's a sudden spike in volume or a sudden drop in volume, very, very indicative. Faceted search, I haven't discussed a lot of the other search tools that we use around this, but faceted search is another now common approach of just slicing and dicing the data and just reducing what you've got. So even after you've used the clustering and the categorization, now you can use these other search tools to really shrink down what you're looking for and come up with really key documents very, very quickly. So that's essentially the learning. This technology, as I said before, can be used for investigative analytics. Essentially, this is a form of whether it be audit or risk or security, or just figuring out, hey, where are my documents about so-and-so? Trying to find contracts, old emails, very powerful. It could be used for HR in ways that people can't imagine today, but you can go through and look and see who's communicating to whom and about what. There's lots and lots you can do with this. Okay, I will now take questions. And one last point, actually. If you've got lots of data, this is actually a good use for machine learning here. If you're trying to get to the cloud today and you've got a data center full of old stuff, you can use machine learning and AI to categorize what you've got, and it will tell you what you've got, and you can tell what's useful and what's not useful. And you can use that to really trim down the junk and pull in the good stuff. And that's the stuff you may want to migrate to the cloud versus keeping it around forever. So that's another very powerful use. Okay, thank you. Okay, questions.
Hi, Quinn. We have a question, and it is related to your page 22 of your deck, where you mentioned adding people, perhaps marketing and engineering, or
Right.
by geographic location. How does the machine learning deal with the variations and possible potential contradictions between these groups?
Aha. Okay, very good question. So let's go back to this particular screen here. You've got a person in the middle here. This expert is judging the documents. So you start with your initial training and you've measured the training and you've gone, okay, fine, I need additional people. So you've gone and added in additional people. It's important that the expert is truly an expert. They should have been using the analytics tools, the concept search tools, the clustering and what have you, to make sure they understand the language contained in the collection. So if strange words are used or coded words are used or abbreviations are used, the expert should be aware that this is actually an abbreviation for this longer word, or this is a code word. This was the engineering word versus the sales word for exactly the same product. So as you add these additional people in, the expert is the person who's going to say, computer, you need to learn about this. So they're going to teach the computer, or they're going to teach the computer they like it, or teach the computer they don't like it. But essentially, it's the expert's role, and then the computer will pick up on that. And again, if there's an area of fuzziness, the computer may make some predictions, and the expert's job is to say, no, not that way, this way. And again, after you've run the training, go through, look at, pull a random sample and make sure the computer's got fully understood it. If not, iterate through again with a few more examples and make sure that the training is properly stuck. But you're going to get regional differences, you're going to get linguistic differences, but it really does come down to your subject matter expert and how much or how well prepared they are to train the system. The system is only as smart as the expert. So we named our company Orca Applied Intelligence. The applied intelligence is the application of intelligence of the subject matter expert to the machine learning. Hopefully that's clear. Next question, please.
Thanks, Quinn. I was wondering if you could talk a little bit more about managing the amount of data and, share with us your opinion on collect everything and then utilize some examples that you said to categorize and organize it, or if it is better to start with a more conscious approach to data collection.
Let's talk about data volumes. Data volumes can be absolutely wicked. We've seen people with 100,000 emails. And you go, well, are 100,000 emails related to our topic? Maybe yes, maybe no. And if you go back through backups, say you are still using tape backups, computer tape backups, you take that person's email again and again and again and again, and you take them across a 10-year period or a 5-year period, you could be dealing with very, very high levels of duplication and near duplication. So a near duplicate is a document which has been modified. So I take a contract and I modify 20 words in the contract. My original contract is a near duplicate of the next version and the next version. And for big companies, it may take a year or 2 or 3 for contracts to be negotiated. And there can be hundreds of versions times however many copies. So when you're thinking about data volumes, think about, how do I remove duplicates? How do I identify near duplicates? And again, what do I bring into my training model? Because the volumes can be absolutely overwhelming. Okay. Another question. I didn't quite see that. What was that question? Can you please read to me?
Sure. What public domain AI tools would you recommend to use for the process described if you want to start and learn?
I'm not sure. I've got my own. So, there are a number of tools out there. Amazon has got some. Azure's got some. Um, the question comes down to literally the training model and how many documents you have to go through to teach the model. There are a number of approaches to tackling this task, and you really have to understand the workflows needed. Some workflows are sloppy, and you have to put in 15, 20, 30% of your documents, which is really not a good way to do things. Others are very efficient. So, but Amazon does have some. There's generally, what we're seeing in the market is there's people who do not understand text analytics, and they are taking the wrong approaches. They are using keyword approaches. And the challenge you get with keyword approaches or focusing on keywords is that bias that I was talking about, where you don't recognize the additional words that were used or the additional language that was used. Likewise, if you're relying on dictionary meanings, so there's a process called LSI, latent semantic indexing. And the problem with LSI is it expects dictionary or thesaurus usage of language, and that's not the way it always works. And so that can result in false positives. It can result in low rates of accuracy, low rates of recall. So understand whatever technologies you use, do research them, understand where they're strong, understand where they're weak, and learn. If you've got any questions, please reach out to me. I'm happily help you. I've been doing this for a long time, and it's something we have a passion for as a company. It's what we do. But there's some great technologies out there, and I like to think ours is some of the best, but that's just me. Oh.